Poisson distribution. This lesson is relevant for the Cambridge A-levels, probability and statistics too. I will start with an example. A student finds that the average number of amoebas in 10 milliliter of pond water from a particular pond is 4. Let me summarize the information. Average number of amoebas equal to 4. Average number of amoebas, I can call it as lambda. So lambda is equal to 4. And the sample size here is 10 milliliters. I also can write this information as X is Poissonly distributed with the parameter lambda, and according to the sum, X is Poissonly distributed, that lambda is equal to 4. Assuming that the number of amoebas follows a Poisson distribution, find the probability that in a 10 milliliter sample, there are exactly 5 amoebas. Look, we can write probability X is equal to 5, which exactly 5 amoebas is equal to, and how are we going to find the probability? We can find the probability using this formula. So this formula says probability X equals to 5, lambda which is equal to 4, and we know that X is equal to 5, multiplied by E value minus lambda, which lambda is equal to 4, and X factorial. According to this sum, X is 5, so we have 5 factorial. The probability that in a sample of 10 milliliters, there are exactly 5 amoebas is 0.156. You can give these values to the calculator and you will get the answer as 0.156. Continue the sum. There are no amoebas, so we are going to find the probability that there are no amoebas. So when there are no amoebas, the X is equal to 0. And we are using the same formula, which lambda to the power X, 4 to the power 0, multiplied by e to the power minus lambda, e to the power minus 4, divided by X factorial, which is 0 factorial. So the probability that there are no amoebas is 0.0183. Also, the next part, the probability there are fewer than 3 amoebas. So how we could write this? Probability X is less than 3, because the sum says there are fewer than 3 amoebas. So X less than 3 means when X is equal to 0, which there are no amoebas. X is equal to 1, there could be 1 amoeba. And also X is equal to 2. There could be 2 amoebas. So we use the same formula. Lambda to the power 0, which is 4 to the power 0, multiplied by e to the power minus lambda, which is e to the power minus 4, divided by 0 factorial. And you add that value where you have 1 amoeba, which is X is equal to 1. And you add the value to X equals to 2 using the same formula. Use the calculator, you will get the answer as 0.238. Let me continue. At least 1 amoebas. What do you mean by this word at least 1 amoeba? So you're going to find the probability of X being minimum 1 or more. So in that case, we don't know or more means to which extent. So X could be equal to 1, X could be equal to 2, X could be equal to 3, and etc. So it's not easy for us to find each probability separately since we do not know what's the end x value is. What we do, when the probability of x is greater than or equals to 1 is given, we can easily find the probability of x equals to 0, which x equals to 0 means we don't have any amoebas. And as we know that the total probability is always equal to 1, we can subtract the probability of no amoebas, which x equals to 0, from 1. So we could get the total probability of x is greater than or equal to 1. So it says probability of x is greater than or equal to 1 means that it has at least one amoeba or more in this sample of 10 milliliters. We could easily find the probability of x equals to 0, which the probability of there are no amoebas, and subtract it from the total probability, which is 1, and it gives you the answer for probability of x is greater than or equal to 1. Also, the last part, at most 2 amoebas. At most refers to the maximum of 2. Maximum of 2 means where x equals to 0 plus x equals to 1 plus x equals to 2. You use the same formula and we can write it as probability of x is less than or equal to, because it says at most. So it's maximum of 2 such 4 to the power 0, which is lambda to the power x, multiplied by e to the power minus lambda, which is e to the power minus 4, divided by 0 factorial. You add it to x equals to 1 as well as x equals to 2, and you add all three probabilities. And the total probability is 0.238, which the probability of at most 2 amoebas, maximum of 2 amoebas. About the Poisson distribution. A Poisson distribution is a tool that helps to predict the probability of a given number of events happening in a fixed interval of time. Also, it is a discrete probability distribution. Let me give you an example. The number of emergency calls received by an ambulance call center in 1 hour. You can see I have highlighted discrete probability distribution in blue, as well as the word the number of emergency calls. That means you will get how many calls. So that is discrete. And fixed interval of time means 1 hour. Next example, the number of cars arriving at a petrol station in 10 minutes. Number of cars, how many cars? That is discrete. And the fixed interval of time is 10 minutes. So the Poisson distribution refers to the probability in a fixed interval of time. If you are deciding whether a Poisson model is appropriate, remember that the events should occur independently, singly, random, average rate should be constant. So when you read the question, you will understand it specifically used these words to show you that it is a Poisson model. This is an example as well as a past paper question. An airline has found that on average, so word on average says it's Poisson. 1 in 100 passengers do not arrive for each flight. and that this occurs randomly. Again, the word randomly says it's Poisson. For one particular flight, the airline always sells 403 seats. The plane only has room for 400 passengers. So the flight is overbooked if the number of passengers who do not arrive is less than 3. Please look at this. The sum says the flight is overbooked if the number of passengers who do not arrive is less than 3. Use a suitable approximation to find the probability that the flight is overbooked. Let me summarize the sum. Number of seats always sold 403 per flight, and one passenger doesn't arrive for every 100 seats. So if one does not arrive for 100, then for 403 seats, 4.03 passengers don't arrive. So it's clear, it's ratios. 1 for every 100, then 4.03 for 403 seats. So in this case, the average lambda value is 4.03. Flight is overbooked if the number of passengers who do not arrive is less than 3. It is said in the sum. It's specifically said in the sum that the number of passengers do not arrive less than 3. In such situation, only the flight is overbooked. So what we have to find here is, if all of them arrive, that means no absentees. 1 doesn't arrive. 2 don't arrive. So x equals to 0, x equals to 1 and x equals to 2. So this is the summary of the information that I took from the. So I'm going to explain this using the probability distribution table. X equals to 0, 1 and 2, and I'm going to find the relevant probabilities. How am I going to find the relevant probabilities? Using the formula, and I know the lambda value, which is the lambda value is 4.03. So when x equals to 0 means that all of them are present, no absentees. So I substitute the values 4.03 and the x value is 0 multiplied by e to the power minus 4.03, which is the lambda value, divided by 0 factorial, and the answer is 0.0177. I will substitute x equals to 1. My answer is 0.0715. I will substitute x equals to 2. My answer is 0.1443. So the probability of x is less than 3 where the flight is over is 0.234.